Hey guys, what's the crack? Yeah, Chatterjee, you know. Hey Arya. Arya, did you get the link now? Hi Mina. Oh, it's Angel. Sorry. Hi Lydia. How are we all doing today? The weather's took a bit of a turn, didn't it? So hopefully today the sun's gonna come back, eh? School starts in what? 2 weeks, right? Hi CFK. How are you feeling about going back to school? Are you ready? Wait, hold on. GCSE results are in 2 days, right? As well. So I guess you're all going back to school. What day is today? Today is Tuesday, Wednesday, Thursday. So is it Thursday? So all your guys' results, eh? No, don't remind you. Area, you'll be grand, honest. You're definitely grand with physics. I'd be shocked if you weren't grand with your physics. After just having a few lessons with you, like, Lydia, you're scared. Yeah, fair. I guess that's quite hard, isn't it? I guess if you're worried about your results. But at the same time, you kind of know, like, if you're a pupil who's always been killing it through school, always get grades 70s and 9s, there's no chance you didn't get a 70 and 9 in your test, right? Hi, Rajan. So does that mean you'll not be on lesson on Thursday then? I think our lesson Thursday is 11 to 12. Is that a bad time for a lesson then if that's results day? Will it just be me? Oh, really? Aria's Angel, isn't it? Angel, that's raging. Maybe she's just worried about, I guess it's a bit of a sesh, right? But at the same time, you should tell her she have faith in you. Be like, Mum, you know I'm going to do good. And you have receipts, right? Angel, is your school like business attire for a sick form? Sorry, and are you all gonna go into school actually to get your results? You're gonna get them. Oh, I don't know how it works in GCSE. Can you actually get them online? Did like the school post them to you or anything? Or like is there like an online platform where you can go on to and see your results? Into school. Going in. They email you, going into school. I actually remember getting my GCSE results. I hated it. So that you know how everyone's opened up their papers in front of everybody? I literally took mine, left, went down the town and sat on a bench and I bought myself a chocolate bun before I opened them. It wasn't a chocolate bun, it was like one of those one with the icings on top of it. So that when I opened it, I could have like I had something to cry with or something to be happy with either way. I just sat at the time by myself. I don't know where my parents were. They didn't go with me. Yeah, I mean a comfort food. I didn't need it, thank goodness, but you know, you always panic a little bit. I'm eligible for my EHCP, which will hopefully be for 6 weeks, and hopefully I'll be able to get my dream sick form. What is your dream sick form? Area. Oh, it's 1101. What is your dream sick form? I'm guessing this is all the same people we've had before, but just in case there is anyone new that hopefully joined us today. So just a little bit about me. Again, I loved physics and results day, like I said, for mine, I remember freaking out and I remember I wouldn't go anywhere near my friends because I didn't want them to see me either upset or happy, right? Like I think it's quite hard to be both. It's because if you're happy and your friends are sad, you feel rubbish. And if you're sad yourself, obviously you feel rubbish. Um, but yeah, like if you're a smart kid and you're doing summer school and you're ready, like you're on it. And if you're anyone here, your physics is pretty solid as so far. I wouldn't be stressing if I was your teacher, never mind your mom, right? And then when I got my results, I decided to do biology, chemistry, physics, math. So the three sciences and math. I just liked science, and I didn't know which one I liked better. And you're probably a lot of you in the same position, right? You don't know if you want to be, if you're good at science, you don't know if you want to be a doctor, you don't know if you want to be a surgeon, you don't know if you want to be a pilot, you don't know if you want to be working in a lab. So again, you don't have to know, right? You guys are like, what, 15? So my career choices changed significantly over the few years, right? So you just have to make sure you've got the grades so that you can change when you need to, don't you? Okay, so just to see how we're doing, can you give the first one a go? So what is each of those graphs telling us? So just pop in the chat. What is A telling you? What is B telling you? And what is C telling you? Pop in the chat. Hendon School. I've actually never heard of it. I'm going to write it down so I can Google it after. Hendon School. Do they have a really good physics department, or what is it about the school that you love? Psychology. So I actually, so at university in the States, it's a bit different from the UK. So in the UK, if I chose astrophysics, I would only study astrophysics. In America, they make you do like a rounded stuff. So I did astrophysics and I did loads of psychology. So if I would have stayed at uni another year, I would have had a psychology degree. But I just don't want to stay there for another year. But psychology is mad interesting. I really enjoy it, especially if you're into neuroscience. Okay, so what we're saying, A is stationary, good job, yes. Thank you. Area, CFK says B is accelerating, good job, right? Because remember that day we looked at the gradient. We see the gradient is quite low here, and the gradient's getting steeper, 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 steeper. So it means the velocity is getting greater, 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 greater. So clearly B is our one that is accelerating. Nice. Amina agrees, good job, Lydia. And C, we're thinking deceleration. Yeah, good job. Good job, deceleration, right? Because, oh, actually, no. I said good job and I didn't mean it. I'm sorry. It's not deceleration. Yeah, good job. Because remember, what the gradient of these lines give us, the gradient of these lines gives us the velocity. And this one has got a constant gradient. So we're going to have some constant velocity. We can get a fixed number. Okay, where this one we couldn't get a fixed number. The velocity is always changing. That's why it was accelerating. Because remember, decelerating, just because it's on the chat there, decelerating would be a curve like this, where the gradient's getting less deep, less deep, less deep, less deep, less deep. But because it's a fixed gradient, like we said there, it's going to be a constant speed, like Rajan said, a constant speed, and clearly this velocity is negative. So it's nice that Rajan said there, if we have a negative velocity, what that means is change direction, right? Which is nice, so good job. So remember, this graph would be deceleration. Okay, what do we think now for C, D, and E? So what do these graphs tell us? C, D, and E. What are these graphs telling us? Hendon School, they have a unit for artistic people like me called HARP. And Area, how do you find these lessons? It'd be actually really useful, Area, if you find these lessons useful, because if you could post something in Trustpilot, so like other parents could know that this is useful. Because I think sometimes in school, like I don't want to speak for you, but I think sometimes in school, if you're autistic or if you have ADHD, because there's so much going on all the time, it's hard to focus. And I think that's a little bit of a worry of a parents, right? To know whether if the chat is going crazy, if this is something that is manageable or helpful for you. So it'd be nice if you wanted to put a review in Trustpilot, just to like let other people know whether you find this useful or you don't. But yeah, thank you for sharing as well. Okay, so we're saying C is a constant speed. Nice, good job, because we see the velocity time graph. So the velocity is fixed the whole time, so that would be our constant velocity. Nice. We're saying D is a constant speed. So remember, C is our constant speed, because remember now we're looking at velocity time graphs. So say that number there was 10. It's constantly going at 10 meters per second. Whereas D, we're starting down here at 0, and the numbers for velocity are increasing over time. So Amina says D is going to be a constant acceleration. Good job. It's going to be a constant positive acceleration, because we know the gradient of that line is a fixed number, so we can find out what that acceleration is. And then we're saying E is going to be, good job, E is going to be a deceleration, because what we can see is it starts at a fast speed and it slows down over time. We're going to get a constant deceleration because I can actually calculate what that number is by doing the vertical divided by the horizontal. Yeah, really nice, good job. Okay, so for this one, I'm going to sketch it and then see if you can give a go at it. So remember we did Suvat's last lesson. So remember we just set up S-U-V-A-T. So just remember, down, we always use negative numbers because it matters about direction because they're vectors. And up, we always use positive numbers because it matters about direction for vectors. So what we've got here, I'm just going to draw a picture because it helps me out. We've got a man standing on a wall. It says he throws a penny vertically upwards, and we know what goes up must come back down. So there's my direction that that's going to go. And then it says here that the well is 45 meters deep. So we know this height here is 45 meters. And we know the time from the from the penny left his hand to hit the ground, we know the time is 3.4 seconds. So we want to figure out what speed, initial speed, remember is u, because our alphabet goes u, v, x, y, z. So u is the first speed, and then v is our final speed. So give it a go. See if you can figure out last lesson how to use these suvats. Remember, they're over here for you. Just trying to pop your numbers in and then figure out what is the speed the penny left his hand, u, and the speed it hit the water, v. So give it a go. Lydia says, I didn't get 13.24. So maybe just be careful about, remember, down is negative. So think about what acceleration is. But thank you for being first to give it a go. Area, how it works normally for A levels, what you normally get for GCSEs, you do normally get the same thing, which is good. And it's good that your school, I know you said you want to switch schools, but it's good that your first school supported. Will you feel that? Amina, in your physics exam, the alarm went off 5 times. No way. Did your school apply for access arrangement, or not access arrangement, for a special, oh, there's a word for it, I've forgotten it now. It's like special conditions. It's something like, I can't remember what it is, but like something goes wrong in your exam, the school can inform the exam board, so they should like give you extra percent, because 5 times, that would panic anyone. If you get really good results, don't bother mentioning it. If you don't get the results you wanted, I would mention to the school, asking them if it actually went off 5 times in the middle of your GCSE physics exam, did the school apply just to tell the exam board that's what happened, because that'd be quite stressful. Yeah, so Angel, thank you. So A we're going to use is negative 9.81, because remember acceleration, so remember key stage 3 we use 10, GCSE we use 9.8, but for A levels we use negative 9.81 because the acceleration due to gravity is always pulling us down. Nice. What we're using for S? Area, did they write to the exam board? Amina, you did get consideration. That's good. Yes, it is consideration. You're right. Thank you, Amina. Thank you, Area. Monkey pickle pants. Lucky you. Do you know what it'd be like if the fire alarm went off 5 times your exam? You're lucky it didn't happen to you. Yeah, so Angel, that's maybe where some people are going around there, right? So remember, if it was 45, that means it's 45 meters upwards, right? But it's not going 45 meters upwards, because remember, our direction matters. It's going 45 meters downwards. So remember, S is displacement. So I think that's where it went wrong. S is displacement. So remember, displacement means how far away did you end up from where you started? If you look at it, it ended up 45 meters below where it started. So that's why the displacement is going to be negative 45 meters, okay? Yeah, Angel, thank you. Yeah, negative 45 meters. Okay, so now we know what A is, we know what T is, and we know what S is. Can you figure out what U and V is? So which suvat are you going to use to figure out what U and V is? Okay, so I would probably start with S equals UT plus a half of AT squared. So over there, we're just plugging in our numbers. So S is our displacement. Remember, it ends up 45 meters below where we started, equals U, our initial speed, we're trying to figure out. T, we know, is 3.4, plus a half of A, we know, is negative 9.81. And T, we know, is 3.4. But again, we have to square that 3.4 because it's T squared. Aishan, good morning. So can we figure out what U is then? Can anyone solve this for what U would be? You have 3 exams in one day. It's intense. Your hand probably hurt at the end, eh? So hopefully we weren't plugging our math here. When I did it earlier, I figured out that we can solve this to be negative 45 equals 3.4 times U. And we solve this out, so I do 3.4 squared times negative 9.81 times by half. I get an answer of negative 56.7018. Rajan says 11.70. I didn't get that. Maybe I typed my calculator wrong. So hopefully we're seeing here negative 45 equals 3.4 U negative 56. So remember, when a negative comes over the magic bridge, it becomes a positive. So I have is negative 45 plus 56.7018. equals 3.4u. So Amina, beautiful. Yes, good job. U is 3.44 meters per second. And thank you, typing in the new way. Good job. And just in case you have joined us, remember in GCSE we write meters per second, but in A levels we write ms minus 1 because the indices matter. Yeah, nice. Good job. So what we do is negative 45 plus 56.7018 gives us an answer there of 11.7018 equals 3.4 times u. So I just want u by itself. Hopefully everyone can see we just divide both sides by 3.4. We divide both sides by 3.4, we get what Mina said there, which is 3.44 meters per second. Okay, so now we know that u is, can we now figure out which one of these we're going to use to find v? I quite like this one, so I probably do this one. So v equals u plus at. Can we figure out now what v is? Yeah, Angel, beautiful, good job. 3.44, nice. And it makes sense we've got a positive number, right? Because clearly we can see the person threw up. So now we know u is 3.44. That positive number makes sense because it is going upwards. So we're trying to figure out what v is now. Lydia, what a star, good job. So Lydia's answer makes sense, right? Because she got a negative number, which tells us it's something going down. Makes sense because it's falling down. And she got negative 29.91 meters per second. Hi, Gurjot. Meters per second to negative 1. So what she did was u, which is 3.44, plus a is negative 9.81, times by t, we're told was 3.4. So what we do there was just plug in our numbers. I get 3.44, negative 9.81 times 3.4 gives me negative 33.354. So when you solve that out, you get negative 29.91 meters per second. Yeah, Amina, awesome. Angel, awesome. Yeah, good job. So hopefully we're feeling quite good about SUVATs then. Okay, so when that topic comes up in school, because this is one of the harder questions, so that's why I wanted to do it, to see if you could like think it through. And just remember, hopefully a lot of you saw there, the biggest mistake probably just forgetting what directions your positive, your negatives. So remember, if you're always taking down as negative, everything has to be negative. So if you use negative 9.81, you have to do negative 45 because the displacement is a vector. You see, you want to where it ends up from where you started, and it ends up 45 meters below us from where we started. Yeah, so grand. Okay, so what you saw today is we're doing resolving vectors then, or resolving forces. Okay, so I just want to see what we already know from our math. Okay, so you wouldn't have done this in physics. Triple physics, there's a little topic on it. Depends what if your teacher's chose teacher or not. So how do we calculate this resultant force? What math do you do? So can you figure out what the resultant force is here? Yeah, it is Pythagoras, Eshan. Yep, good job. So Pythagoras, just if we don't know from math, is a squared equals b squared plus c squared. Join the arrows up to make a right angle triangle. Yep, good job. So my arrows are already quite nice. They're nose to tail. That's nice. I've got a right angle triangle, which is why we can do what Eshan said there, Pythagoras. And Angel says 5. Just be careful of that little n, right? Remember, little n means nano, like nanometers. So it's 5 newtons to the right. Do you agree? Do you disagree? So it'd be 5 newtons to the right if one was going 15 newtons to the right and one was going 10 newtons to the left. The resultant force there, that's when it would be 5 newtons to the right. But we can't just add and subtract them because they're going at right angles to each other. Okay, so because they're going at right angles to each other, we can't use that. So Aishan and Mina says it's 18.03, and I got that too. Good job. But remember, forces are vectors. So it's great that everyone got the size of it to be 18.03, but I also need a direction. So put in the chat when you figure out what its direction is well. So just so you see, Pythagoras, so A is always the longer side, or the hypotenuse. This will be your B, and this will be your C. So all I need to do to find out what A squared is, I do 15 squared plus 10 squared. So then to find A, I have to take square root of 15 squared plus 10 squared. And we do that math, it comes out as 18.03, capital N for newtons. Okay, northeast, Aishan is right. Good job, because north, never eat shredded wheat. So you could say it's going northeast, but I actually want to know what that angle is. So do you remember from math, how do you find that angle? So how do you find the angle from math? Okay, there's 2 ways to do it. Some of you learned SOHCAHTOA. I never learned SOHCAHTOA. Yeah, Eshin Trig. I never learned SOHCAHTOA, so I can't really remember how to write it, but it's like S-O-H, SOHCAHTOA. Is that right? SOHCAHTOA. Sohcahtoa, Sohcahtoa, something like that, right? But I learned top, cat, sat, on, and orange, and held horribly. So that's how I did it. So for me, tan is opposite over adjacent. So tan theta is opposite over adjacent. Ah, there we go, I see it now. Tan theta is opposite over adjacent. So tan of theta is going to be the opposite, which is 10. So my tan of my theta is my opposite, which is 10, over my adjacent, the one beside it, is 15. So then if I want to find out what theta is in my calculator, I just hit shift tan or inverse tan of 10 over 15. And hopefully we all got the same angle, which is what Lydia got, I agree, and what Ishan got, good job, is 33.7 degrees. Yeah, fab, 33.7 degrees. So that's what the angle is there. The angle there is 33.7. And the way we talk about it is you want to say it's 33.7 above the horizontal, okay? So my final answer here is going to be is 18.03 newtons at 33.7 degrees above the horizontal. Because the horizontal, remember, is just that horizon line, the horizontal. Yes, I can, area, yes. Okay, so then this is your horizontal here. Remember, that's your vertical. So what we find is it's 33.7 degrees above that horizontal. Okay, so just do another one of practicing this. So area, just give me a quick, if we're good. We've seen this in math classes, yes? So this is more of a math topic. You probably all did Pythagoras in your math classes. Area, awesome, thank you. Ishan, do you need to? Yes. Okay, and that's something actually year 12s really struggle with. So in GCSE, it's very different from A-level physics. In GCSE, if you have the right answer on your answer line, the examiner won't look at all your math because you have the right answer, right? They're just gonna like tick, that's it. In your A-levels, it doesn't matter if you get the right answer if you did the wrong method, right? So you do have to have your method through there. So the examiner will look for your method to see if you plug the numbers in the right way. Because sometimes you can do the wrong math. It's not very often, but sometimes if you do the wrong math and get the right answer, because you did you will end up getting the right answer, but because you did the wrong math, you actually don't understand the math. So yeah, in physics, you got to show everything so that the examiner can just walk through what you've done. Because even if you get the wrong answer, if you typed, let's for example say, instead of typing in 15 squared, you made a stupid mistake and type in 14 squared. The examiner, if they can follow through your math, you'd only lose 1 mark there. So that says it's not going to be, say it's a 5-mark question. You'd only lose 1 mark because they can follow through the rest of your math. So even though your final answer is wrong, if the answer matches the math that you did, you'll still get marks, right? So the method does matter in year 12. Okay, so just make sure we're good. Can you tell me now, what is the resultant force here? So again, what's quite nice, if we've done head to tails, so our resultant force is going to be in this direction. What is that resultant force and what is the angle? If you just plug in the values and solve in a calculator, would I get full marks? So it's a bit different, right? Because I don't know, you've not seen a year 12 paper yet, but these type of questions, remember I told you there's multiple choice last time? At the end of the paper, in paper 1 and paper 2, there's like 18 multiple choice questions. So because they're multiple choice, you either get the mark or you don't. So there'll be like an A option, B option, C option, and D option. So for this question, you'll have to just pick one answer and say they're right or wrong. So they actually don't care about your working out there. But if the question was at the start of the paper, so you know the SUVATs things we were doing at the start there, if that question was at the start of the paper, then it does matter they follow for your math. So only the multiple choice section that you don't have to worry about them following for your math. Okay, so we're saying 21.21 newtons at 45 degrees above the horizontal. Rajan, that's awesome. Good on you. Yeah, perfect. Lydia, it's in there too, just missed it. Yeah, good job. Nice. Easy, right? So hopefully we're thinking a squared equals b squared plus c squared. So we're thinking a squared is equal to 15 squared plus 15 squared. So to find a, I just do the square root of 15 squared plus 15 squared, which gives me a final answer of 21.2 newtons. And then to find that angle, we know that tan of theta is equal to opposite over adjacent. So theta is my inverse tan of my opposite over my adjacent to get me a final answer there of 45 degrees. And really nice that you figured out this angle is 45 degrees and it's 45 degrees above my horizontal, which is perfect. Yes, or Ashan, you could have remembered about your isosceles triangles rules. Yeah, which is perfect. Okay, so the reason we're doing this is because you have to apply this in physics in different examples, right? So hopefully you'll see like we're starting to build on this a little bit through the lesson. Okay, we're just going to do one more because this is the type of thing now we're going to start using in physics. Okay, so can you figure out what the resultant force is here? Okay, so I want to see if you can give it a go, but I would like to give you some hints before you start. Okay, so I know a lot of people will see here that I've got 80 newtons. Yeah, you could do reverse fag, Ashan, but that's going to take you a minute, right? So this is what I teach in my classes. There's 10 newtons, and there's our angle, 30 degrees. I want to know the resultant force is. So the first thing I got to do is separate this into whatever it is horizontally and whatever it is vertically, okay? So instead of doing tan theta is opposite over adjacent and sine theta is opposite over possibly trying to figure out, the way that I did it and the way I've learned it is, do you see how this vector here, if I go down through the 30, I go through the angle. Anytime you have to pass through the angle, you always use cosine. So this is going to be 80 cosine 30, okay? And anytime you don't go through the angle, so you go, it's called against the angle. And if like the way I learned it in school was if you go against the angle or against God, you commit a sin, right? So if you go against God, you commit a sin. So if we go this way, because we didn't go through the angle, we committed a sin, so that's going to be 80 sine 30. So what we actually have here is we have an upward vector of 80 sine 30, and we have a vector going towards the left of 80 cosine 30, and we have another vector going towards the left of 10 newtons. Okay? So in my calculator, if I solve out 80 sine 30, it gives me a number 40. If I solve out 80 cosine 30, it gives me 79.28 newtons. Yep, I'll do it again. Okay, so maybe I'll do like another example. So I'll change my color so I can show you again. So let's say that was 10 newtons, and let's say that angle there was 5 degrees, okay? So if I want to find out what the horizontal is, and I want to find out what the vertical component is, the fast way to do it is that if you take, and it works all the time, you take your vector and you go through the angle, because I went through the angle, that's cosine, so that's 10 cosine 5. But if I went to find the vertical, I didn't go through the angle, right? Because we didn't go through the angle, we went against the angle, so against God is a sin, so that's my sine. This is going to be 10 sine of 5 degrees, okay? If I show you another example, so let's do a down one. Let's say that was 6 newtons, and let's say I want to find the horizontal and the vertical. And let's say there is, that's what we do now, let's say 20 degrees, okay? If I go through the angle, it's always cosine, so that downward vector there is going to be 6 cosine 20. If I want to find my horizontal vector there, I didn't go through the angle. If you don't go through the angle, you went against the angle or against God, that's what 6 sine 20. Okay? So if we look back at our example here, I've got, just going to draw again here for you. It works because it's the same, it works because it is doing trig, it is remembering tan theta is opposite or adjacent, it is remembering cosine theta is adjacent or hypotenuse, so it is the same thing. It's just because instead of having to go through that in your head all the time, this is the same rule, just simplified, right? It's the same, it is trig, it's just because it's always the same math, it's just a fast way to remember it. Because you don't want to waste time in your physics paper, you get like 1 minute for question. So again, there's my 80 newtons, and there's my 30 degrees. So if I want to figure out what the horizontal and the vertical is, here I'm going through the angle, so that's my 80 cosine 30. And here I'm going against the angle is like against God or sin, so that's my 80 sine 30, okay? So that's what I did there. So over here, if I do 80 sine 30 in my calculator, I get 40. If I do 80 cosine 30 in my calculator, I don't get 79. I'm being stupid there, sorry. I get 69.28. Okay? So now, if we want to simplify this further, now what I really have is 40 newtons going upwards, and I have 69.28 going to the right, and 10 going to the right. So in total, I actually have 79.28 going towards the right. Okay, so now can you figure out what the resultant is? What's the resultant force? So we simplified this to get this. That's what all that math was for, to simplify that to get that. So now, what's the resultant force? Okay, so what's the resultant force here? Okay, hopefully you're thinking first step is they're drawn wrong, right? I can't have tail. So what I really have here is I have 40 newtons going upwards, and I have 79.28 newtons going towards the left. So I want to figure out what this resultant is. Oh, sorry, I won't go that way. What the resultant is. 88.8 newtons, says Ishan, and I agree, good job. So again, to find this side, we're going to do a squared equals 79.28 squared plus 40 squared. So then a is giving me the square root of that whole answer, which gives me exactly what Ishan said there. It was going to be 88.8 newtons. Nice. And then what's the angle? So yeah, the force, so remember minuses before was given a direction up or down, but now I want a theta, I want an angle for theta. So the force, that's just the magnitude, that's the number of it. I want theta now. So can you find out what theta is? So maybe either give me this angle or give me this angle. Anyone you want, just tell me which one you're giving me. So you can give either angle X or Y, doesn't matter, as long as you tell me that it's below the horizontal or that it is below the vertical. 27.8. I got 26.8, but maybe I typed in my calculator wrong. So did you do shift tan of opposite or adjacent? Did you do shift tan, maybe I typed it in wrong, of opposite, 40 over 79.28? 26, I got 26.8, Amina. Yeah, below the horizontal, good job. So what you found was X, so you did tan is opposite over adjacent, so 40 over 79.28. So to find tan of theta, find theta, which was below the horizontal, I got 26.8. I think you did 2, you might just typed it in wrong. Yeah, Amina, yeah, good job. 26.8 degrees, nice. Below the horizontal, nice, good job. So this one we're going to practice quite a lot because this is what it comes up in physics, right? So you see we kind of start it easier to start and then we build it up now because now we have to resolve it and then remember that we have those verticals. So I'm going to highlight our steps really quickly again so we practice another one, okay? So what we saw here is I had 80 newtons at 30 degrees above the horizontal. So first thing we need to do, because we did have a 10 newtons also going towards the left, I had to figure out what component of that 80 is going towards the left with the 10 and what component of the 80 is going up. So what we did was, because we didn't go through the angle, we made it sin, so that was 80 sine 30, which gives me 40 in my calculator. And then to go towards the horizontal on the left, we got 69.28 newtons because that's 80 cosine 30. But then because we also had a 10 going here, that's why we had to add them together because they're both going in the same direction. So that's how we got 79.28 is our final resultant force going towards the left. And we have 40 newtons going up. So then what we did now is we have our up vector and our vector going towards right. We want to find our resultant. So what we did was we joined our arrows heads, tails. So we have 40 going up, 79.28 going towards the right, and that's when we did our Pythagoras to get our final answer of 88.8 newtons at 26.8 degrees below the horizontal, right? So it's quite a lot of steps in math, and we're going to see this now with different examples, okay? Okay, just to make sure we're good then with what we did, because that was me trying to teach it to you all in one go. So can you really quickly figure out what is the horizontal and vertical component on A? How many marks would that be? It depends where it comes up in the test. So in physics, that's not going to be a final question. So I'm going to show you some of the questions that will come up at the end. So do you know in your work pad there, if you flip right to the end, that's what the questions will look like in your exam. That was just me trying to teach to you how you get to those questions, right? So we're not going to start straight with past paper question. I'm trying to teach you the math first, and then when we get good at the math, then we'll show you how it looks like on your past paper questions. Yeah. Okay, so really quickly and just see if we're okay with the math. So then you shouldn't have to use trig, just use the rule I told you. What is the horizontal component? And what is the vertical component? So give it a go in our calculators. So hopefully you don't have to do trig, just remember my rule. What's the fast way to do it? So hopefully you're thinking here, I didn't go through the angle to get the horizontal. So if we don't go through the angle, it is a sin, because when against the angle, sin against God. So that's sine 40. And in the vertical, we went through the angle, so that's good. That's 350 cosine 40. So Aishan says we're going to get 268.12. Don't know why I got 268.12. Good job, that's your vertical. 268.12. Nice, newtons. My horizontal, nice. I got the same as you. Good job, 224.98. Yeah, Aishan, perfect. Nice, newtons. Angel, vertical, good job. Yep, fab. And a horizontal, fab. Okay, so everyone see that's quite a quick way now to do the math. Okay, if we don't go through the angle, we commit a sin. We're going against God, it's a sin, so that's why it's always sine in that direction. Okay, so down here now, I've got a box and slope. This is quite popular in physics. This comes up quite a lot in the multiple choice questions, so it's actually only 1 mark. But this is just me trying to teach the math. So it says the mass of the box is 10 kilograms. So I've got 10 kilograms is the mass of my box. So we know weight always pulls things straight downwards. And there's my angle 20 degrees. So what I want to do is figure out what is the component here that is perpendicular to the box, and what is the component here that is parallel. So can you find out what x and what y is? So what's our perpendicular and vertical components of that weight? So what's the perpendicular and vertical components of that weight? Hopefully you're thinking the first thing, that's not even a weight, right? That's a mass. So we've got to put it into a weight, W equals mg. So we do 10 times g, we know is 9.81. So our weight is 98.1 newtons. So instead of writing 10 kg here now, we're going to write 98.1 newtons. So if we want to find y, we go through the angle. So my y is going to be 98.1 cosine 20. I find x, I want to find the component of the weight in the x direction. I didn't go through the angle, so that's a sin. So that's going to be 98.1 sine of 20. So calculator, we'll do 98.1 multiplied by the cosine of 20, which gives us 92.18 newtons. Yep, Aishan, perfect. 98.1 multiplied by sine 20, which gives us, yep, Aishan got the exact same as you, good job. 33.55 newtons. Yeah, nice, good job. Okay, so everyone good with that? So first thing here was the warden. They like to do this in your test. They'll give you the mass, but you know that's not force. So the first thing we had to do was put it into a force, which is our weight, W equals mg. And then we saw if we go through the angle, we know we always use cosine. If we go against the angle, we always use sine. Right, because sine is like a sin, it's against God. Yeah, nice. Okay, so we're just gonna practice this again. This is me trying to show you now where we're gonna start using it. Okay, so what it says here is we've got a man and he's obviously hanging from his gymnast, right? Maybe watch the Olympics. So the first thing I know about him, I'm gonna model him as a point particle, right? We're not gonna try and draw all these forces on him. I know he's a man, so he clearly has a mass. So I know weight is always going to pull him straight down. It's my first force. Weight is always going straight down. He's holding on to 2 ropes, so I know there's going to be a tension in each rope. Okay? So how we draw this as a free body diagram means how do we represent all the forces? Clearly on my man as a point particle, I'm going to have his weight pulling him straight down. I have tension, which is going up and to the right, some direction there. So I'm going to have one tension going this way. And I've got another tension going up and to the left. Sorry, I don't know my right and left. This one's up and to the left, this one's up and to the right. So up and to the right, there's my other tension. Okay, so we can clearly see this is how we model our free forces on this man. And then hopefully you can see that what we'll start doing then is we'll start resolving these forces into horizontal and vertical components. Okay. Okay, so to make sure we're good, with drawing diagrams, This one, can you have a go at these in your work pack, and then I'll draw them up too. So in your work pack, just have a go at these. So I want you to draw me a free body diagram. So you have to figure out what forces are on them first, because we can't start doing the math to calculate the forces if we don't know what forces are actually on the objects, right? So either start drawing them in your book or start typing in the chat. But I want to know if I've got an elephant on the ground. Hopefully you're thinking, I'm not going to bother drawing a full elephant in my physics test. I'm just going to model it as a point particle. If he is standing on the ground, I know the elephant will have some weight pushing him down. And he's not falling down, so there must be an equal but opposite force pushing him up, called the support force. And I draw them both the same size because the resultant force on him is 0, right? Because he's just stationary. Okay? So can you just either draw, or number 2, describe to me if I've got a Ferrari and is accelerating towards the left. It's a terrible looking Ferrari. Okay, I've got a Ferrari accelerating to the left. Hopefully we're thinking, if it's accelerating to the left, F equals ma. If it's accelerating to the left, there must be a resultant force to the left. So a bit bigger force going towards the left. And then we know there's going to be some friction or air resistance going towards the right, which is going to be much smaller. Then we'll hopefully know a car has a mass, so there will be weight pulling it down. And then it's not falling down, so there will be a support force, equal opposite size, pushing it back up. Yep, CFK, lovely, nice. Okay, a toy car sliding down a plane at 30 degrees above the horizontal. So that's the stuff you've practiced. So let's say I've got my rump. It's 30 degrees above the horizontal. There's my horizontal, 30 degrees above. I'm not going to bother drawing a toy car. I'm going to draw a point particle. And I know the first force I know is weight. Weight always pulls it straight down. I know, like same way here, they've got a contact force with the ground. So there's my ground. So the contact force, remember, is always perpendicular to the ground. Same way as here. It's always perpendicular to the ground. And then it says the toy car is trying to slide down the way. So if it's trying to slide down the way, I know there must be friction trying to pull it in the opposite direction, because friction opposes the motion. Okay, next one is a roller coaster. So let's say we're doing loop-de-loop. That doesn't look like loop-de-loop at all. So loop-de-loop, we've got a roller coaster here. So there's his tires. There's my people hanging upside down. So the first thing we know, the roller coaster has a mass. So we know there's a weight force pulling it straight down. And the same thing here, look, the support force is from the base through the object. So it's from the base through the object. So the support force here is going in the same direction as the weight. Okay, because it's from the base through the object. And the last one is we've got a ball suspended in the air by 2 strings. The string on the left is 30 degrees above the horizontal. So there's my horizontal. The string on the left is 30 degrees above that horizontal. And the string on the right is 45 degrees above the horizontal. And then we clearly know any ball is going to have a mass, so we're always going to have weight pulling it straight down. Okay, so again, this was just us practicing drawing the diagrams, because we need to know what way the forces are going before we can start calculating what they are. Okay, so what I want you to try now is a challenge. So it says the tension is 30 newtons here, so we know that's 30 newtons. And we know this tension is 40 newtons. Can you figure out what the mass of the ball is? Give it a go. So what's going to be the mass of this ball? So we know W equals mg. So in order to find the mass, first we got to do is find out what the weight is. So how can we find out what this W is now that we know what these 2 forces are? Pop in the chat. What would you do? How to find W is, now we know what those 2 forces is. Hopefully you're thinking, I got to figure out what this vector is in the horizontal and the vertical direction. Because remember, if things are balanced, up equals down. So here, remember, S equals W. So we're trying to figure out what is the vertical component of that 40 newtons and what is the vertical component of that 30 newtons. And then because they're balanced, we know what goes up must be equal to what goes down. Yes, Ishan, perfect, good job. So what math do we do to figure out what the vertical is? Because again, we know this rope is going to have some horizontal component, the 40 Newton rope. We know the 30 Newton rope is going to some have horizontal component, but those don't matter about weight, right? It's down equals up. So the weight has to be equal to whatever the vertical component of the 40 newtons is and the vertical component of that 30 newtons. Yeah, good job, Ishan, brilliant. So the 30 newtons, if we go this way, we didn't go through the angle, committed a sin, so that's 30 sine of 30. And again, like the 40 newtons ones, like Ishan said, yeah, and you add them in, good job. The 40 newton ones, we didn't go through the angles, because that's a sin, so it's going to be my 40 sine of 45. So now if I want to find the weight, clearly I have to do 30 sine of 30, because it's going up, plus the other thing going up is 40 sine of 45. So hopefully we get the weight then to be, the mass is 1.53. I didn't get 1.53. Maybe I typed my calculator wrong though. I'll double check too. Where's my calculator? 43.2, yeah. Is that for weight or for mass? So again, what we're trying to calculate is 30 multiplied by sine of 30. And we have to add it to, Ishan, I think you just forgot about the other one. So you pop both of them in the chat, but you forgot to add them together. Because remember, they're both going up, so you just add them together. So it's 15 plus 40 multiplied by sine of 45. And then you get what Amina said. Yeah, nice. So the weight is 43.3. Nice. 43.3 newtons. Good job. Yeah, Ishan, there you go now. So then if we know the weight is 43.3, we know W equals mg. So 43.3 equals some mass times by 9.81, because we know G is 9.81. So the mass then is going to be 4.4 kilograms. Yeah, perfect. Nice. Good job. Okay, so this is the type of thing. Question 5 is the type of thing that comes up in physics. And you can see why we practice resolving our forces first and find our angles, because that's what we're going to come into a lot. Yeah, Angel, divide by 9.81. Nice. Yeah, good. Okay, I think we'll skip this one just for the sake of time because I want to show you some actual examples. Okay, yeah, we'll do the real life example. Okay, so first thing is we have to model him, right? So we've got a person of mass 70 kilogram abseils down a vertical tower. So here's my vertical tower. So I'm going to draw my vertical. I've got a person, and clearly I'm going to model him as a particle because it's too much effort to try and draw him. It says he's got a rope at 40 degrees to the vertical tower. So there's a rope attached to him that's at 40 degrees to the vertical, right? That makes sense. There's my vertical, there's my horizontal, is 40 degrees to the vertical. So that's that angle in there, 40 degrees. It says draw a free body diagram for the person and label the forces. So hopefully you're thinking, we always know there's going to be a tension here. We always know he has a mass, so we know his weight is pulling him straight down. And then his feet are in contact to the ground, so there has to be a support force at that right angle to the surface. Okay, so it's my free body diagram. Yeah, area, no worries. My free body diagram. Okay, and then this question says, how do we show it's an equilibrium? So we've got weight going downwards, we've got his tension force going upwards, and his support force is going towards the right. So because it is a closed shape, that's how we always show things are in equilibrium. They're closed shapes. Okay. So now that we've drawn this all, can you prove that the tension is 900 newtons? Have a go. How do we prove that the tension, what math we do? Maybe type in the chat. What math do we do to show the tension in that rope is 900 newtons? This is similar steps before. So remember, we know that if things are in equilibrium, they're balanced, it means all the up forces equals all the down forces, and all the forces going to the right must be equal to all the forces going to the left. And this part, this math, is going to help you find the 900 newtons. Yeah, work out weight, Ishan, good thing. So the first thing we're going to do is find out what that weight is. So W equals mg. We're told his mass was 70 and G is 9.81. So we know what the down is, right? So that's your big hint. We know what the down is. How do we find out what tension is? How do we find out what tension is? Hopefully you're thinking, okay, I know this angle in here, but it's kind of hard to do anything with that because tension's going in this direction. So hopefully you're thinking from math. Remember the Z rule of math, that this angle always is equal to this angle. So if there's my Z, there's my vertical, there's my Z, there's my other vertical, that means I know that this angle here that I'm just shading in, that angle is 40 degrees. My triangle is ordered weird. Do you see weight's going down and then this tension is going in this direction because it's going northwest, and then my support force is going to the right. This is not me trying to draw this is not me trying to draw a triangle for trig. This is me just trying to show you that anytime forces form a closed shape, that's how we find things are in equilibrium. Okay, so hopefully you're thinking, what I have here now is I have the weight going down that we just calculated was m times g. So 70 times 9.8. And we have a tension here, and we know that angle there is 40. So how do we find what tension is? How do we find what the tension is? If we know that up has to equal down. So remember, up has to equal down. We know what the down is. So 7a times 9.81 must be equal to the up. Mitsuri, 2 more years? Are you GCSE? Angel says 686.7. 686.7 is not what I got. How did you get 686.7? Maybe you're just ahead of me in math or a bit behind me in math. So hopefully you're thinking 70 times 9.81. Okay, so 70 times 9.81 is our down, right? It has to equal the up. So 70 times 9.81 is 686.7, right? So 686.7 has to equal the up. So 686.7 has to equal the up. But can we figure out what the up is? So 686.7 equals the up. If I look at it, if I want to find up, hopefully see you go through the angle. If you go through the angle, that's t cosine 40. So 686.7 equals t cosine 40. So remember, the whole point here is trying to find what t is. So hopefully we're seeing, Aishan, perfect, good job. Hopefully we're seeing what we do is 886.7 divided by cosine 40 gives us t. And we do that math, you get exactly what Aishan got. You get 896.4 newtons. And it said show it's roughly equal to 900. We just did that because if I write this to one significant figure, that is 900 newtons. Nice, 900 newtons. Good, lovely. And then if we're good now, can you figure out what the normal reaction is? What's S now? So I'm going to change colors now to figure out what S is. So remember, S, we know right equals left. So S, remember, is going this direction, and it has to equal whatever's going towards the left. Why do you divide? Do you see this line here? So it says 686.7 equals the up, and our up is t times t cosine 40, right? Because t through the angle is cosine, so my up is t cosine 40. So to get t by itself, we have to divide both sides by cosine 40 to get rid of it from that left-hand side. Yeah, Lydia, awesome. So then when you divide by cosine 40, you get this number that we always write in our test to show that what number we got. And then to one significant figure, that's how we get 900 newtons. Okay, so now we're trying to figure out support force because we know that right equals left. Aishan, 576.21. Aishan, good job. This is your topic, eh? Yeah, good on you. So hopefully we're doing what Aishan said now. I know right equals left. So to find that support force, I need to figure out what component of the tension is going towards the left. So I can see if I go this way, I didn't go through the angle, so that's t sine 40. Kind of sin, we didn't go through the angle. So S is equal to t sine 40. And we just calculated what t was down here. So S is equal to 896.4 multiplied by sine 40. When you plug in your calculator, you get exactly what Aishan said there, which is going to be 576.2 newtons. He liked trig. Well, if you're doing physics, trust me, trig comes up literally every topic somewhere. Gabriel, you just woke up? Yeah, I'm not really sure with a year 12 lesson if you can just rock up 50 minutes in, it'd be good. That's actually really good advice for you going into year 12, right? Because I have so many students where they're trying to get from class to class or they need a bathroom break because now they're in year 12, they're not getting late marks if they're in late and they can walk around when they want. But you have to be really careful because if you miss the first 10 minutes, especially with physics class, you're going to walk in and be gone, right? So just make sure you want to be early for those classes, yeah? Okay, yeah, we will go for it again. Okay, so highlighting red is a horrible color. Let's highlight in yellow. Okay, so we're trying to show the tension with 900 newtons, right? So what we have here is that we said we had a person and we told he has a mass, so he must have a force pulling straight down. That was his weight. And we know W equals mg, so to get his mass into a weight, we just multiply by 9.81. So that's how we figured out the down component there of his weight is equal to 686.7. I know there's a support force going through his feet at 90 degrees to the surface, so that's how I have a support force going towards the right. And I had a tension force because it told me that the tension was 40 degrees to the vertical. So that's why I got that 40 degrees was in there, and then my tension force. That's really hard for me to figure out what to do. So that's why I remembered my math rule, that if it's a Z shape, those two angles there are equal. So I found my Z shape, and that's how I figured out the angle there is also 40. So that's why I simplified my drawing over here to have my 40 degrees here. And I know if I take my tension and I went through the angle, it gives me cosine 40. So the upward component there was T cosine 40. And because it's in equilibrium, we know that it must be balanced. So that's why we knew our up forces equals our down forces. Yeah, alternate angles, Aishan. Yeah, thank you. So our up forces equals our down forces. So the down force we find was 686.7 has to equal whatever up was. And the up we just found was T cosine 40. So T cosine 40 is 686.7. So just to get T by itself, we divided both sides by cosine 40. So I divide both sides by cosine 40, I got a final answer of 896.4, which I did prove was 900 newtons because it's the same thing if I went to one significant figure. Then the next question asks us to find what the normal was, that support force. And again, we know because it's in equilibrium that our right must equal our left. So my support force must be equal whatever component of that tension is in the horizontal. So this way we didn't go through the angle, so we went against God, we committed a sin, that's T sine 40. So we know that T sine 40 must equal S. I know what T is because I just solved it down here, so I just plugged it in. So T sine 40 equals S, which gives me this final answer, T sine 40. Okay, are you happy? Yeah, Ishan, this topic comes up in, so I don't know if you all watch Neil Does Math, but he does a lot of this as well. Rajan, awesome, good job. Okay, for the sake of time, I'm pretty sure we can get this one done. Okay, so some of you asked me what does it look like in exam questions. So this is a past paper question. Okay, so now we're getting to past paper questions. So we've done all the math. We're gonna try a past paper question now. So it says, here's my picture. So if you've got it printed out, I would highly recommend just drawing around the picture. It says 3 ropes are attached to a ring as shown. That makes sense. Rope A, rope B, rope C. This is an equilibrium. So what we know from equilibrium, it means that all the up forces equals all the down forces, and all the forces going to the right must equal all the forces going to the left. So it says the tension in rope A is 210. That's okay, they've written tension for us, 210. It says calculate the tension in ropes B and rope C. So how do we figure out what rope B is, and how do we figure out what rope C is? Okay, so you can give it a go. It's quite nice math now that we know what to do, so just give it a go. So can you calculate for me what's the tension in rope B and what's the tension in rope C, knowing that it's in equilibrium? So hopefully you're thinking, I've got 210 newtons here at 30 degrees above the horizontal. So the first thing I need to do is resolve that into its vertical and its horizontal components. Rope C is 105 newtons. Yeah, good on you. It is. Good job, Mason. Rope B, 181.87 is exactly what I got to, Lydia. Good job. 181.87. Nice. Yeah, good job, guys, right? Because it's an equilibrium, up equals down. So whatever this vertical is, must equal the down. So 210, if we go this way to find the vertical, we didn't go for the angle. We committed a sin, so we went against the angle. So that's my 210 sine of 30. And this vector, we went through the angles, it's my cosine, so that's going to be 210 cosine of 30. So we know that because it's an equilibrium, all my ups has to equal all my downs. So rope C must have been equal to 210 sine 30. And all my rights equals all my left, so rope B must be equal to 210 cosine 30. Yeah, nice. Yeah, perfect, Angel. Yeah. Okay, so hopefully we're seeing that's quite nice. Right, we're quite happy with that one. And we actually flew through that, so will we try one more then? this one. So remember we looked at this earlier when we talked about a man on our ropes. We model him. So again, rather than have a man, I'm just going to model him as a little particle. It says he's suspended by 2 ropes. So I've got a rope here going up and to the right. So a rope here going up and to the right. I've got a rope here going up and to the left. And it says the tension of each one is 0.41 kilonewtons. So 0.41 kilonewtons and 0.41 kilonewtons. It says the angle between the ropes and the horizontal is shown, 65 degrees. So I'm going to mark on my horizontal on my diagram now. And there's 65 here, and there's 65 here. You feel sorry for the man. What is the weight of him? So what is the weight of him? Because we know he has a mass, so there has to be a force pulling him down called his weight. So what's his weight? Lydia, that was quick. Hold on, let me see if you're right. Is that you found his mass? I found his weight, so bear with me to find out what his mass is. So you 7, 3. Lydia, what a star! Good on you. Yeah, good job. So his mass is 75.7 kilograms. Good on you, Lydia. Nice. So yeah, so you actually made it harder because it just asked for his weight. So his weight is 743. Yeah, good job. So his weight is 743. So see if everyone gets the same thing as Lydia. Yeah, so you made it harder because you found his mass. Yeah, Aishan. Oh, is it cosine, Aishan? Why 650? Oh, 65. 410 cosine. Area. That's really nice. Yeah, Lydia, good on you. Okay, so hopefully first thing you're thinking, that's in kilonewtons, so I want to get rid of it. So 0.41 kilonewtons is 0.41 times 10 to the power of 3, or 0.41 times 10 to the power of 3 is going to be 410, right? So instead of writing 0.41, I probably rub that out and write 410 because it makes more sense to me. So 410, and where's the other one? Rub that one out. Is 410. Now remember, trying to up equals down. So we're trying to figure out what component of this tension is going up and what component of this tension is going up. So remember, if we go this way, we don't go through the angle. So that's why it's going to be T sine, commit sin, 65. We went this way, we don't go through the angle. So it's T sine of 65. And we know what T is. T is 410. We know the up has to equal down because he's in equilibrium. So what we're saying, 410 sine of 65 plus 410 sine of 65 equals his weight. Or we can write that as 2 times 410 sine of 65 equals his weight. So when you plug that in, you'll get the same answer there as Lydia. Aishan, are we okay why it's sine and not cosine? Right, because we didn't go through the angle. So if we look here, if we want to find what the vertical is, I didn't go through the angle, and if we don't go through the angle, it's against the angle, that's why it's sin, right? Cosine would be this direction. So that would be T cosine 65. And that would be T cosine 65. Okay, how do we feel? Don't understand. Don't understand why it's sine. Do you see in the picture there that I just drew over here? Oh, you're good now? Yeah, we're good. Yeah, so you see, if we went through the angle, that's where it's cosine. But this way we went against the angle. So we go against the angle, that's when it's going to be T sine 65. You're good. Happy days. Angel, you're good. Lydia, that was so fast as well, so good on you. Yeah, that was a really good job. Okay, so that was like pretty hardcore math again. I feel like all of our lessons are hardcore math, but hopefully you're starting to see like physics is basically just math, and they just repeat the same things all the time, right? So this lesson was just building on that. So you will have probably a couple lessons in school on this topic as well for the year, okay? So please remember, like this we're trying to show this to you guys for free, and then please put some things on Trustpilot, right? Tell like how you feel of it. Do you think it's useful? How is it compared to school? Because we're trying to outreach a lot more people to let them know they have options, right? Because we all know school's quite difficult to learn at right now. You're very lucky you've got an awesome physics teacher, right? Hopefully y'all guys do, but let's be straight. Ain't gonna be nothing compared to me, right? Okay, well, that's us done. So you guys are free to go. And I hopefully will see you on Thursday. So the lesson, remember, is 11 to 12. Then get your results in the morning. So it'd be really nice if you get good results and you can come on and like tell me how you did. But I totally understand, obviously, you're going to go celebrate and you're like probably want to go out with your parents, so maybe catch up. Aishan, that is so nice to say. I hope you've told your teacher that all the time. And you're very lucky that you had a good physics teacher. Catalina, I didn't even see your name there before, but thank you for saying bye. Bye, Amina. Lydia, you're confused to begin with, and then you just like flew through at the end there, eh? So good on you. He taught you string theory. That's quite intense. Yes, Angel, hope we see you on Thursday. You guys will do amazing, so good luck. Like, look at the math you just did here. Math and physics is way easier, right? It's just basically doing W equals mg and that's it. Bye, Amina. Okay, I'm going to tap out. So hopefully this helped you guys out, and hopefully I'll see you on Thursday, and all the best again.